having me here today. I feel a little bit like an imposter coming from psychology amongst all of you, but I'm, I guess, glad that someone has requested this kind of a presentation. So you can interrupt me at any time if you have any questions. And over in our department in psychology building, we love research and we love data, so I will be going over some data when I'm presenting a certain point, so do feel free to just stop me.
First question, is it like from the perspective of the presenter or the perspective from the audience?
It's the perspective, I would say, of the audience. So what can you do so your audience understands things better? Okay? Yes?
Are you going to be reading every single slide on the PowerPoint so we all wish we died?
Maybe half of them. Okay, we'll see how it goes. So a bunch of the research that I will be presenting today comes from one of our labs, and I was a part of this lab at some point, and it's our Applied Cognition and Education lab. A lot of the work has been done by now Dr. Barb Finessi, who's a postdoctoral fellow now over in kinesiology. And over in our department, we have this big introductory psychology course, and most of the lectures are up online. And a big question for us and investigating all these issues with presentation design is, okay, how can our students learn better, and how can we make our multimedia presentations better for the benefit of our audience? So first, I'm going to ask you, when you think of the word PowerPoint or presentation, what comes to mind?
Microsoft.
Good one.
Beamer.
Anything else? When you think about PowerPoint or...
People in suits. People in suits with buzzwords.
Okay.
Big words.
Big words. Difficult.
Word art.
Yes. Oh, that word art is so good. And presentation. So we, or any of you might use PowerPoint at different points throughout your careers or your education for different purposes. I know many professors use PowerPoints to lecture or to provide information. And really, when you sit down and open up your computer and you're going to create a PowerPoint or whatever equivalent of this multimedia visual presentation, it's really thinking about the goals. Why are you creating this PowerPoint? That should be a first question. You do want people to remember what you said a few weeks from now, as opposed to just, okay, presenting something, you put it up there, and then it's gone forever. So one of the first few things is thinking about the goals of creating a PowerPoint. So when I'm going to talk today in an outline about multimedia design principles, as the question you've asked, it is from the perspective of what can we do for our listeners, for our audience. I'm going to cover 5 main multimedia design principles: redundancy, image superiority, coherence, contiguity, and segmentation. And I'll touch just a little bit at the end on presentation skills themselves, so that's from your perspective as the presenter. What could you do now that you have this tool in front of you? First, verbal redundancy. It really refers to, having a presenter or a lecturer, in this case, give a presentation. They have a bunch of words on their slides, a bunch of sentences, and they pretty much read verbatim, word for word, what's going on the slide. And you can have even more extreme examples such as these. You have a lot of things going on, but you do have this verbal redundancy of reading off what's on the slide. And from a cognitive perspective, verbal redundancy really has to do with our limited working memory capacity. So you can think of working memory sort of like mental juggling. As information comes in, you're trying to store it, you're processing it, and then you're trying to store it, then more information is coming in, and so on and so forth. We have a finite amount of this resource, of our limited working memory capacity. And as you add more and more information, the faster it gets depleted. So at the beginning of a lecture, at the beginning of a presentation, we have a full tank of working memory capacity. Things are going great, you're ready to learn, you're ready to absorb information. But as we go on, and as we add more things to our cognitive demands, like you have verbal redundant text and reading it off the slide, and you have visual cues and auditory cues, you start getting a little bit overloaded with that. And our limited working memory capacity starts depleting. You start veering towards empty. a little bit of research to show you this. For example, you have this lecture, and the audio is the same as both presentations that I'll talk about. And then one instance of the lecture, you have this redundant text. So for example, this lecture would be about hunger and eating, and if you would hear the audio and you would see this slide in this experiment, you would hear the audio say, following a restful night of sleep, you wake up feeling hungry and eat breakfast. You don't just stop eating once you've achieved a feeling of fullness, for most of us. Let's take a closer look at the regulation of these two simple sensations, hunger and fullness. So you could have a slide like this, or you could have a slide like this, which is called a complementary slide. So you're really hearing audio as one thing, but the visual information is different. So you don't get the same input from both of your senses. So see, you talk about restful night of sleep, wake up feeling hungry and eat breakfast, and then you have this breakfast. And looking at the data, we have here on the x-axis, we're going to look at when participants were presented with the audio only. So you just heard whatever I read off the slide. Other participants would see the redundant slide with the audio, and a third group would see the complementary slide with the audio. And on the y-axis over here, you have percentage correct on a test that they took after they saw a lecture. Lectures can range from these experiments from about 10 to 20 minutes, and they do have a quiz at the end that's about 20 multiple choice questions long, and 10 of them are more factual, while 10 of them are more applied type questions. They're a little bit more difficult. So audio only, how are participants performing? You see, it's not so bad. An average of about 60-something% after just watching the lecture. In the redundant one, you might see it's an increase in number, but these two are not significantly different. They're pretty much statistically the same. So between you listening only to a lecture and seeing this text on the slide, it's not giving you any advantage in terms of your learning. However, when you look at the complementary group, the ones that saw the images and heard the audio, there's a statistically significant difference between this group and then the rest of the groups. You perform much better. And now you tell that to students, and sometimes, I walk in, and since I do research in my PhD in education, applied cognition, I try to tell students in my first tutorial, in my first classes, here are some of the things you should know about. You're kind of met with a little bit of resistance, and they're like, nah, that can't be it. So in these experiments, they also wanted to see, okay, what are the students' perceptions of this, or your own subjective perception. So here on the x-axis, we're going to look at participants being asked, how well did you understand this lecture? And how difficult did you think this lecture was? So our perception measures. And on the y-axis, is their perception rating on a scale of 1 to 4, 1 being, I didn't understand at all, or it wasn't very difficult, to 4 being, I understood this pretty well, or it was very difficult. And in maroon, we're going to have our redundant instance, and in gray, the complementary one. So in terms of understanding, those who saw the redundant lecture reported significantly higher levels of understanding than those who saw the complementary lecture. So they thought, okay, all this text on slide, I got it, and I understood a lot better, and they found it less difficult versus the people who saw the slide with just the images. They found it significantly more difficult. So that's the subjective perspective of our students, of people who are seeing these presentations. But then when you look at the objective comprehension, the actual test scores here, mean comprehension score on the y-axis, and again presentation style, you see redundant and then complementary. It's significantly different. They do much better on the complementary than they do on the redundant, but they think otherwise. So why is this happening? Why do we still have slides like these when we can have more slides like these that actually help learning? Well, it can be a little bit of a vicious cycle. Our students might see professors who have these slides full of text and they get used to that, and then they go into a different class, and if the professor doesn't have slides like this, or at least the professor thinks, okay, there's an expectation for me to have this slide, and there's this whole literature on perceptual fluency. That's really very much, you like things more, you find them more attractive, the more familiar they are to you. So So as students are coming into university and you see more and more instructors that have these type of slides, they're more familiarized with them and they like them better, even though it doesn't help their performance. So how can we solve this? Really by showing you the redundant and complementary one is the principle of the superior images. So having an image that replaces something, for example, like this. You can be talking in a biology class about the heart, so you know heart is divided into 4 chambers, and then you go on and on and on about the components of a heart, or you can show them an image. Or you can even have a model, for example, in biology to show them something and decompose it and take it, instead of having this whole text. Because we do perform better when we have a mental model of something. And in a mental model, for example, in our psychology courses, if we talk about basic neural processes and we start describing what happens when neurotransmitters reach the dendrites, they travel down the axon, and they move further down. I could be saying all of these, I could be writing all of these for them, but giving them some sort of mental model is kind of meeting them halfway. Instead of them having to do all the work to basically translate all those words into the mental model and then to go further and try to understand it, this is pretty much providing it for them in the first place. Okay, next principle, the coherence principle. And you have to bear with me for these, because they make a point. So in the coherence principle, and if you think of all of these multimedia designs, it's really thinking about the name of the multimedia design component. You want a coherent presentation, and you also want a presentation that doesn't have any extraneous information that's not really relevant or valuable to what you're talking about. You also don't want to have components in your multimedia design that's distraction or disruption. So for example, if you present this kind of slide or this kind of image, but you're really only focusing right now on talking about the aorta or the left atrium, they don't need to see the rest of this. So as I showed you the graphs before, at the beginning, I blocked off the graphs, I explained the axes, what's going on. There's a lot of information to be had at first. You can have people in your class or during your presentation start mind wandering, and when they come back to your slides, they come back to that, and it's already overwhelming. So trying to not have extraneous and distracting information would help your listeners. It's the same point with having more seductive components. And what I mean by seductive components is having like a cute puppy. We all love cute puppies and kittens, but if you're not talking about cute puppies and kittens, that might actually distract from the point that you're trying to make in the presentation. If you're giving them a break and you want everyone to, okay, just take a mental break, look at this cute puppy, sure, but if you're trying to go through a lecture and talk about something and then you have some irrelevant information there, it may distract your students, your supervisors, anyone from the points you're trying to make. So in this coherence principle, one way that you can eliminate irrelevant information but also bring home the main points of what you're trying to say is having a summary slide. So we saw presenter before, she was really great and gave your concluding points, so kind of the takeaway. And even with that, you can overwhelm students if you find something like this. I found that online. So if you have a summary like that, or if you have a summary like that, it's more like reading a textbook than really summarizing the points that you're trying to make. And we come back to that whole idea of working memory capacity and the coherence principle in a different study. So imagine a part of the audio of this study says something like this. Without visual memory, we wouldn't be able to store and later retrieve anything we see. So some participants saw a slide, and this is just a snippet from a longer lecture, of a congruent. Again, we have this congruent slide, and what does it really mean? You see this picture of mountains come up, and you see store, so visual memory we wouldn't be able to store, and later retrieve anything we see. So you see this person with a little thought bubble, he's retrieving this image that's very similar to what was there. In an incongruent condition, you would have something like in store, you have this cute puppy, and then later retrieve, you have this image of the mountain. And you might not think it's a big deal, you have different images and all that, but violating this coherence principle can affect the knowledge in the participants and your students.
One question.
Yes.
Sometimes, like in the memory, we use keys. Like professor, he made up some irrelevant thing, but funny, like puppies. But after a few years, we can recall, and when we talk to someone who was present in that class, do you recall what the professor was saying about that cute puppy? There he explained those stuff, and suddenly we can, oh yes, I recall. So sometimes, like not relevant things also can be used as memory aids.
Yeah, and I wouldn't really disagree with that. Also, if you're a professor, I would say would kind of attract the idea towards, okay, so I'm showing this picture, but I'm also connecting ideas around this. I know of professors from my department that, you go through a bunch of the literature and a bunch of all of like heavy content, and then you have something that's not relevant. It can break the focus, and you might remember, oh yeah, I remember that instance, but it's more of a episodic memory type of thing that might not work for all people. And as I'll show, it works for some, but it might not work for others. So for example, if you just look at the results for this one, initially they didn't find any statistically significant differences between congruent and incongruent. Okay, so looking at their scores, proportion correct here on the y-axis, there's no difference. But going back to the working memory capacity, when you look at congruent and working memory capacity, there's no real difference. So the participants were also tested. There's actually a test online that you can Google yourself. It's called the O-SPAN task, so O and SPAN. And it's just about a 20-minute task that tests your working memory capacity. And the scores are very distributed amongst people. Some people have a lower working memory capacity, some people have a higher. But for congruent images, it didn't really matter. They did well across the board, whether they were lower on the working memory score or higher. It's the incongruent image, so the puppy and then the image of the mountains, that affected those with a lower working memory capacity score. So for people that you might say, oh, I kind of remember that detail, I remember that relevant thing, they might have a higher working memory capacity and a better ability to incorporate those episodic moments with what they learned. But for those people with a lower working memory capacity, it does affect them. Just that little thing of, showing one image that's relevant and one that's irrelevant. The next principle, very short and sweet, contiguity. I'm not sure how many things you guys present with labeling, but for example, in many disciplines, you can see these kind of images, or you have a graphic, or you have something going on the slide, and then you have some sort of legend like this. The easiest thing to do to make your listeners, attribute these ones to this is really to move them around. If you have that kind of setup, it's just a very small fix, and it just in general helps your participants focus or your students on what you're talking about. The last principle I want to mention is segmentation. So as we go and we explain different concepts, or you are talking to your supervisors about all the amazing progress that you've been doing on your work, you do want to break it up in parts and what you're talking about. And we notice this in our day-to-day lives. If you look at origami, so making a daylily, it is broken down in steps. If again I wanted to talk about blood circulation in the heart and how it works and where it pumps, I may want to just break it down into the different steps and not just have like, this is all what's happening. And segmentation is really taken in, for example, if you're watching videos, if you're watching TED Talks, you might not have a lot of online lectures as we do in my department, but it's really beneficial for people to be able to self-regulate their learning a little bit too. Of course, it's more difficult in a lecture, but that's when you can, tell people, pause me when you need to. If you need a second to think about this, we take a quick break. And the study done by LICS in 2008, they presented their participants with some lectures, and they could either not pause, just go straight through the lecture, or pause. And again, coming back to that whole working memory capacity, we see in this graphic actually from the paper, this just means they didn't have no self-regulation, this, they were able to self-regulate. Again, those with a high working memory capacity are not as affected by all of these differences, but those with a lower working memory capacity did not do as well when they were not able to pause. And again, the time on the actual lecture is not higher than the time spent of the people who couldn't pause. Because just pause, don't rewatch anything, don't do anything else, and just taking a little bit of a break and then continuing on. So in summary, we touched on these 5 principles. So try to keep your redundant verbal text that's there to a minimum. Of course, you can use bullet points, but when you're putting the bullet points up there, they might be for just capturing the attention if anyone's strayed away, and instead of reading them out loud, you might want to say something extra about them. So not really having that word for word. Whenever you can replace those words with an image, with a graphic, and I think our previous presenter had a great example of that, of showing us all the different graphics, and instead of trying to explain. So imagine you have a car here, and a car here, and a car here, and a car here. Having that image really helps. And trying to exclude extraneous information from your presentations and from your topics. And contiguity, whenever you can, align things spatially. If you have 2 visual sources of information, aligning them in space is easier on the working memory load, on your cognitive load capacity, and segment wherever possible. Now, in general, you can take these multimedia presentations, you apply them in a PowerPoint, but just having that PowerPoint and showing it to people is not the whole picture. And going back to what is your goal in creating these PowerPoints and in telling people things, whether it is your supervisor or it is a seminar, it's something else, it's really telling a story. So you may not think of your research project or your classes as really a story, but they are. Okay, if you're talking to your supervisor, like, well, I started thinking about these solutions, I tried them, it didn't work, I thought about something else, and this is what I came up with in the end. So it's really trying to first sit down and try to formulate that story. And one important thing to take away from multimedia presentations is the PowerPoint, or whatever you have up on a screen, is not for you. The PowerPoint is for your viewers. So if you're creating this for the purpose of having lots of text for you to be able to read and all that, you haven't served a good purpose for your audience. So now with fancy technology nowadays, I can see this in presenter view on my computer, I can kind of see what's coming up. So you don't really have to spend any time looking at any notes or putting things up there, because this is for your audience. Having some meaningful titles that captures their attention, only a few points, some images, it's all for them. In terms of presentation skills, I call 3 Ps. Plan. So you do have to plan when you sit down, and sometimes you might not have a lot of time, but you might want to take those 2-3 minutes that you have and plan. And in planning, you want to, again, think of creating that story you can take, and you might think, I'm just talking about the dullest thing, and it doesn't have a story. Create a story around it. Know your audience, that's really important to see how you're going to cater this presentation, and of course always learn from others as you're presenting. Always pay attention to elements that other people have that you might want to incorporate in your presentations. Practice is important, but sometimes people can over-practice. I don't know if you've ever been to any presentations that I've known in my department, they were nervous and they practiced a lot, and they sounded so rehearsed that it was almost like they were reading out a script. It was beautiful, it was fluent, but it might have gone at too fast of a pace, and it just felt too scripted. So practice in terms of how much time it takes you to say things, if you're comfortable shifting from one topic to another, but don't worry about over-practicing. And then the last one is don't panic, okay? Your audience doesn't always know what's coming. You might think you're going over a slide and you're like, oh my God, I forgot to say that one thing. They don't know that. Someone might ask you a question at the end and you're like, actually, that's a fantastic question because you forgot to say that, and they will remind you about it. So I think audiences are usually very forgiving of anyone who's presenting. So just try to plan, create that story, practice, and just be calm and try to enjoy whenever you're giving a presentation, whatever you're talking about. So I want to definitely thank my department. They kept me there for the last 10 years. I want to thank my audience for all your attention. And if you do have any questions, you can always reach me by email or hunt down Dan. Okay, thank you. Yeah.
It's like when you, in like mathematical sciences, when in computer science, we do abstract, we explain in terms of models or abstract things.
Mm-hmm.
Like A means something like inflation in economics, or B means something else. And when you go into more equations, sometimes if there are a lot of variables, you get lost.
Right.
That happens a lot in undergrad and even in graduate classes.
Mm-hmm.
When I keep connecting the variables inside my mind, and the professor goes 2 or 3 slides forward, and I'm lost, and there's the class is like boring. So,
Right.
so in those kind of things, when you have research or you are explaining something where there is a model, you cannot explain all the things visually. Is there any good way to perceive and also to present?
I'm thinking for your example, especially when you have lots of variables and all that, and I've experienced something when in my domain we have lots of acronyms, like many letters put together, and then you kind of forget at one point. If it's useful for the class and maybe your professors to have a little legend at the bottom of each slide to kind of remind you what the variable is. So I was teaching my students, I teach a course at McMaster, and I was teaching my students about all these things like PSS and J&D and SOA, and they all have big names like just noticeable difference, stimulus onset asynchrony, point of subjective simultaneity. I don't remember that. So as I'm even going through it and have those acronyms, I reiterate at the beginning, and I also get them to practice, but I think having maybe a little bit of a legend that people can reference. So if you have graphs and you're presenting something and you had an acronym a few slides ago, it might be good to maybe write it out fully, especially if someone's zoned out and they came back in. Yeah.